Hi everyone, again switching to English. Welcome, thanks for coming. And this is basically the continuation of the talk I just had in the big hall about Lambda and Kinesis. So this one is going to be hands-on part where I'm going to go through some of the things that I talked about previously. And you can ask questions wherever you have them, or maybe in the end of this session, so whichever works for you. So let's start with the setup. I'll zoom out a bit so you can see it. Maybe, yes, that's better. So the code for this demo is in the GitHub repo that you can see here. And I'm going to walk you through that code today, but you can use it later on your own pace whenever you want to. And naturally, you will have you will need an AWS account for that. And a quick note of warning: to use Kinesis, there is no free tier in AWS, so you will end up paying right from the start. But it shouldn't be more than several cents if you just do this demo. But to make life easier for you, in the end of the demo, I can share some free AWS credits for those of you who want to. So just come by and pick the credits. There's a limited amount, but I'm pretty sure we will have enough for everybody. So just take those, and then you can try things out on your own with any other service as well. You don't have to do only this demo with those credits. Okay, so let's take a look at the repository that we have here. So the repository will contain both the code for the producer for our Kinesis stream and consumer. And for the sake of this demo, we are going to be using Lambda functions both to produce the data, or to write the data to the stream, and then to read the data from the stream. And both the code for the Lambdas and the infrastructure itself is in this repo. So if you were listening to Yuri's talk before this, I'm actually using CDK, AWS-specific infrastructure as code tool, or cloud development kit. And I'm not going to go into details of CDK here. It's just used to spin up the infrastructure, and there's a lot of documentation and books on the subject of CDK. Behind the scenes, CDK still will spin up CloudFormation templates, so if you are more familiar with those, AWS uses CloudFormation for infrastructure as code. And CDK will spin up a CloudFormation stack behind the scenes, but it will be just nicely hidden behind an actual programming language. And in this case, we are going to be using TypeScript. And this, of course, will help you to spin up identical infrastructure later on your own whenever you want to, and try things out. And there is a short description of how to use it here in the README. Nothing rocket science. I'm sure it will be easy enough. So let's maybe take a quick look at the infrastructure itself. Not going to go into much details, just to give you some idea of what we are talking about. So maybe zooming here. Right, so the entire infrastructure here is defined as one stack. Once again, you don't need to know much about it. It represents basically a CloudFormation stack behind the scenes. So for the sake of simplicity, I just have one stack. And in this one stack, we create our Kinesis stream. We name it Barcamp stream. It will have just one shard. So it's as simple as this to create a Kinesis stream with CDK. And then we will create two Lambda functions, our producer Lambda and our consumer Lambda. Again, not rocket science. Here we just provide the name of the function, and we just say that it's Node.js and Node 16. So this demo is a bit outdated. It was done before Lambda supported Node 18, but there shouldn't be much difference anyway. The handlers will be the producer handler and consumer handler correspondingly, and some other settings here as well. And Lambda code is located in the Lambda's producer and Lambda's consumer folders. And here, one thing to note, we grant write permission to the consumer and read permission to the producer. Right, the other way around. So we grant write permissions to the producer and read permissions to the consumer to read and write from the stream. And this is done with just one line of code here. And if you're familiar with, for example, CloudFormation, it would require a bit more than that. So it's pretty straightforward to work with CDK. And I have already spun that resources up. So let's go to the console and see them up and close. So this is the Kinesis console, huge size. Here we can see that we have one stream named Barcamp stream, and it has one shard in it and some other details as well. And then we have two Lambda functions. Resolution is killing me. Two Lambda functions, the producer and the consumer, that we just spun up. And there is the producer code, and maybe I will show quickly the configurations or the permissions that I just showed you. So with that one line of code, we added three allow actions to our Lambda. So we allowed our producer Lambda to write records to the stream. So this is how it looks like. So the producer code, we are not going to go into much details here. It just writes record to the stream. I guess the important part here is that let's see if the code will load eventually, maybe. Yes. So the producer code here is very simple. We generate some records, some dummy records. We send them to a stream. So the most important here is that we generate the so-called partition keys, because each record that you write to Kinesis stream, it must have a so-called partition key, which is just a string that you generate. You choose it yourself. So here, for our dummy purposes, I just generate strings which are numbers from 0 to the number of records that we want to write. So it will be 0, 1, and so forth. Yes, please.
Is there a specific reason why are you using Kinesis here, or like it could be SQS?
Of course, it can be anything, but this particular demo and the talk before, it was about Kinesis and the event source mapping component of Lambda, which is used with Kinesis, for example, and SQS as well. But SQS doesn't support the full range of capabilities that I'm trying to kind of display here. But this one is just an illustration of how to use Lambda with Kinesis. Yeah, thank you for a question. So yeah, we generate those partition keys, just strings, and then we basically send those records to the stream in batches. So not gonna go into any details here because there's a lot, but we just generate dummy records here. I will show you what we are writing. So just some JSON, important stuff, something else, and adding a partition key to it. And that's what we write to the stream. Nothing extraordinary. Okay, so the setup part is done. Let's move forward. So let's start with batching. So if you were at the talk before, the first superpower that event source mapping provides us. So we can get, instead of getting individual records from the stream, our Lambda will get batches of records from the stream, and we can configure the batch sizes for that. So let me see. So I will show you that Kinesis, the consumer Lambda, so the second Lambda that will act as our stream consumer. And here you can see that we have Kinesis as our trigger. And if we go down, we can see the details of this trigger, a lot of stuff. So these are all the things that are related to the event source mapping configuration that I was talking about. So these are all the event source mapping configurations. And there are things like batch size and batch window here. So in our case, it's 10,000, and the batch window is not specified. And the consumer code itself is extremely simple at the moment. So let's start. I will be commenting and uncommenting things out depending on where we are in this demo. So in the beginning, we receive an event from the stream, and the event will be containing a batch of records. And here we just log the size of the batch. Let's uncomment the first step. We want also to see what exactly was in that event that we got. And to test things, we will be doing end-to-end testing, so meaning that we will send some stuff from the producer and then see what happens in the consumer. So in the producer, I hopefully created beforehand a test event. Let's see if I have. Yes, I have. So the producer side, we send a test event which basically will tell our producer Lambda to generate one batch of records containing 3 records. So just 3 records that we want to send to our stream to testing things out. So let's send it. Let's make sure that it actually went through. Yes, we sent 3 records from our producer. And to see what happened with the consumer, let's go to the consumer logs that I have here open already. So nice lighting. So we have our Kinesis consumer log group, and let's see what was happening in that log group in the last minute. And it seems to be, the internet seems to be pretty slow here, so so the demo might take time. But
while we're waiting, can I ask a question?
Yeah, sure.
What's the batch window? Is that a timeout?
Yes, it's not a timeout, it's a time interval within which you want to collect that batch of records. So the default one is 1 second, so it means that it will be like if you have like low throughput stream, so the records are coming not frequently enough. So if the window will be triggered once per second, you might end up with empty window or with an empty batch or a batch that contains just one record, which kind of makes no sense for Lambda to process just one record. So we can extend that batch window and make that batch bigger. So that's one thing. But this is like painfully slow. Can it be this slow? Really?
Can I add a
Yeah,
question?
Sure.
Like if the batch is empty, will the Lambda be called?
No, it shouldn't. At least I think it's not guaranteed that it won't, but it shouldn't. But it will be called with one record. So, and one record is pretty wasteful if you think about Lambda invocation. If you have like a huge amount of records coming in, like because Kinesis is often used with big data, like really huge amounts of data, like think millions of records per minute per second. And if you start triggering, a Lambda invocation for each and every record in the stream, well, you will end up in a lot of trouble in the end.
I a little disagree with that statement. I have a use case where it was making a lot of sense to have batch size 1. Imagine a scenario when you want to, like you have a lot of requests, but the requests are processing very fast, and you want to guarantee that the execution of each request, processing of each request, start in the same order as they arrive. In that case, it makes sense to have the batch size 1 because otherwise you can't guarantee that.
No, because with Kinesis you can actually guarantee the order. Kinesis guarantees you the order.
Yeah, but if, imagine there are 2 batches.
Yeah.
Each of which contains 2 elements.
Yeah.
And we have 2 Lambda information.
Yeah, so this will be in parallel.
Yeah.
And if you...
The first Lambda, so
yeah.
Like you have messages 1, 2... Okay, we can discuss later.
No, we can. But if I understood correctly what you are trying to say, if not, we will discuss it later. But if you want to actually have just one Lambda reading events from the stream in order, in that case, you need to have just one shard in that stream, because you will have as many concurrent Lambda invocations as you have shards in the stream. If you have 2 shards, you will always have 2 Lambdas. Even if your batch size is small or big, it doesn't matter. Different shards go to different Lambdas. So if you have different shard, if you have more than one shard, and if you have just one shard, it will always be just one Lambda. So it will always be in order. And even if you get a batch from that shard, the batch, you can process it in order in your code.
Yeah, I was taking parallel with SQS.
But we can discuss later after that. But we finally got something. I already forgot what I was trying to demo. but let's, the incoming event. So here we can see that we got some data from Kinesis. So the event that Lambda gets looks like this. It's a JSON object. And it's an array that contains, it contains an array of records. And each record, here it is, it contains the actual data and some metadata. And our data is here, and all the rest, and the partition key that we written, and all the rest gets decorated while writing data to Kinesis or reading the data from Kinesis. So all the things that you actually wrote there was the data and the partition key. And the data here, you might notice, is encoded, is base 64 encoding, so you have to decode it when you get it. And then there's our partition key that we generated. So as I told you, we generate numbers from 1 up to the number of records. So here we have partition key 0, partition key 1, and partition key 2. That's that. And some metadata. And just a second. And also we have a lot of metadata here, but one important one I want to note is the sequence number is the identifier that uniquely identifies each record within your stream. So just keep this in mind. We will probably see it later if we have time for that. Yeah, go ahead. Well, data is encoded by Kinesis when they said it. It compresses it. And that's how, actually, I think most of the services in AWS, they use base 64 encoding. So you need to pretty much always decode the data when you get.
Compression.
Yeah. Yeah. So we were talking about batching parameters. That's where we started. So maybe I can show you how to create a new trigger. So let's say we don't have a trigger already. So we say we want to have a trigger. And we choose our stream, which is Barcamp stream, and then you can basically just press OK at this point and you will have your Lambda listening to your stream. But here I wanted to show you the batching parameters. So batch size, number of records in each batch. So by default it says 100 apparently. And batch window, the one that I told earlier, the maximum amount of time to gather records before invoking the function in seconds. So the maximum batch window. And if the batch size is reached before the window is over, so that Lambda will be triggered anyway. So it's either a batch size or a batch window, depending which one comes first. Okay, but we don't touch it. So let's quickly show that we can do the same with CDK. So it's actually pretty simple. So here was our stream. And if we scroll down, here is our event source mapping options. So here we just have the very simple event source mapping. We just say that the batch size is 10,000 and that's it. And also we tell that starting position, I haven't mentioned it, but basically we can tell Lambda where to read in your stream, which is the place you want to read in your stream. So there's 3 options. You can either always read just the latest things that arrive, so you don't reread the same records. Then you can specify a specific timestamp within your stream where you want to start reading. For example, you want to reprocess some old records and say, like, give me records from like 3 hours ago, and it can do that. Or it can actually replay the entire stream. So you should, I think it's stream horizontal or something like that. So it will start from the very beginning, so like the oldest data that you have in the stream, and then it will continue from that. But in all our examples, we will use this latest, so the most recent records that you were writing to the stream. And we will be playing a bit with these batching parameters later, but you can see that's like very simple to configure. All right. So then came the parallelization factor. So again, a reminder, and if you weren't at the talk earlier, so with parallelization factor, we can actually tell Lambda, or we can actually, tell Lambda basically how many concurrent Lambda invocations we want for each shard. So instead of having, as I said, like 1 Lambda per shard, we can actually have up to 10 Lambda functions reading from the same shard. If we have like a high throughput stream, the processing happens really slowly. The order order is different equations. We can discuss it later if there will be time. But there will still be ordering, but the ordering will be partition key based. So it will be guaranteed that your records are ordered according to their partition key. But if you want to have more power, you can have up to 10 parallel Lambda invocations per each shard. And once again, this is something that we configure from the trigger. And let's edit it from here. Actually, before it wasn't possible. This demo could have taken even more time, because before that, if the trigger was created, you had to update it with infrastructure as code only. So each time we would have to deploy, but luckily now we don't. So we go down, and I think it's in additional settings, and then we go down. Here it is. So concurrent batches per shard, process multiple batches from the same shard concurrently. And let's get it to 3. So we want to have 3 Lambda instances reading from each shard. And we can't because, what? That's a nice bug. That's something I haven't seen before. Okay, let's try once again. So we have our Barcamp stream, yes, and additional settings. And we go and concurrent batches per shard, 3, and we save. Well, now it worked. Go figure. So here in the details, we can now see that the concurrent batches per shard are 3. If we go to CDK once again, real quick, you would, if you try it on your own, you could comment out this add events or this basic event source mapping, and instead of that, you would uncomment the parallelization factor. And here we just add this parallelization factor 3 parameters. So pretty simple. Okay, so now I'm pretty sure there will be a demo effect here. So I want to test our parallelization factor of 3. And for that, again, let's go to our producer. And now we want to send a bit more records. So let's send 16 records and see what happens. So first, let's see, did it go through? Yes, we sent 4 batches of 4 records. So we only have 16 records, and our batch size was configured to 10,000. So in theory, all the 16 records should go in one batch. So we should only have 1 Lambda invocation in normal conditions. But now, while we configured the parallelization factor, we should see 3 separate Lambda invocations. And let's see if we will. Wow, that's I think that's first time it works from the first attempt. But it's very difficult to see. Okay. So we have 1 incoming event, 2 and 3. I will show you the events themselves. This resolution makes it a bit difficult, but let's try. So here's the first thing. So it's our first Lambda invocation, and pay attention to the partition keys. So in this invocation, we have partition key 2, partition key 2, partition key 2. You see the point, partition key 2. So we got 4 records with partition key 2 only. Then comes the next Lambda invocation. We have partition key 0, 3, 3, 0, 3, and so on. So we will only get partition key 0s and 3 in this second invocation, and the third one apparently will be partition key 1. Yes, partition key 1, partition key 1, partition key 1. So when you use parallelization factor, the entire partition key space is split into subspaces, and each invocation will take care of a subset of partition keys. So they will not ever overlap between lambdas. But let's return our...
Preserve the order also?
Yes, to preserve the order. But the thing with Kinesis is that they say that it guarantees you the order in general. But the fact is that if you are using anything like partition key, the best kind of case that you can get is order based on the partition key. So not all the records, like if you're familiar, for example, with FIFO SQS or FIFO, I think SNS works the same way. So they have this group ID that they use for ordering. So these partition keys will pretty much work similarly in this case. So you will have ordering within that one group, but here it can span several partitions. So, okay, ordering in Kinesis is shard based. So in one shard, you will have all your records ordered. But if you use parallelization factor, you can't do that anymore because the shard is, split. But the subsets will not overlap of that partition key. So per subset of partition keys, it will still be ordered. You know what I mean?
So subset, it will be ordered.
Yeah, in the subset. So basically, as you have seen, you will probably have several partition keys in the same batch, but you will only have that particular partition key in one batch. So they cannot be kind of splattered or in that one lambda. So that order, partition key based order, is basically preserved in that way. I hope I explained it clearly. It's easier to illustrate with a picture. And actually, in the blog post that I linked in the talk, there is I hope, nice illustration of that, so you can go check that out. Maybe it will make it a bit clearer what I try to say. So let's return to the concurrency 1. And I have a feeling we're going to run out of time really, really badly, but let's see what we have time for. All right, so next up was the error handling, my favorite part and maybe the longest one. So let's focus on the way that Lambda handles errors, because that's really crucial for, in my opinion, any service that you use. First and foremost, go and check how error handling works. What are the limits for the service? What happens if things go wrong? Because they will go wrong at some point. If you have big enough scale, it will fail. I promise you it will fail. So just kind of always go check things out beforehand. That will save you a lot of gray hair. So let's focus on how we configure error handling. It's really, really simple with Lambda and Kinesis. But let's first look what happens if we don't configure anything. So go with these notorious defaults, which I was talking about. So let's see what was the setup here. So I'll go to my code. Let's comment the step 1 because we don't want to log so much anymore, and then uncomment this. So we will start with simple code with no error handling. I think it's there. So yeah, so we will have this process record, processing every record in a batch, and it will just print the partition key, and then in the end it will parse the data because base64 encoding. So basically, as I was saying, you should always parse your data, but it's pretty straightforward. So we parse our records, but in the middle we also introduce the so-called poison pill. And again, we do a very dummy implementation here just for the sake of this demonstration. We kind of tell Lambda that if the partition key of the record was 1, it was a bad record. That's just throw an error, say there was a poison pill. So every time we get a batch and it gets to the record with partition key 1, Lambda will throw an error. And it will print the partition keys before that. So it will probably print the partition key 0, and then it will throw an error, and 1, and it will throw an error. And then in the end, if all goes through, it will print the data. So in the beginning, we shouldn't see any data because we will always stumble upon that one partition key. Okay, so yeah, let's go test it out. I think I deployed it already. Yes, I did. So let's go and send again just a small batch, just 3 records. Here we go, we test. And we send the 3 records, and then we go through to the logs and hope that this time it's faster for some reason. Yeah, of course, log propagation takes some time, but luckily internet here is even slower than the log propagation, so we are fine. So here we are. We received the batch of size 3, and then we printed the first partition key, and then the partition key 1 threw an error. We said, oh, sorry, this is a poison pill. And then does that. It doesn't continue from there because Lambda threw an error. But then there is one more retry, partition key 0, throw an error, partition key 0, throw an error. Oh, you see the point. This will continue basically for 24 hours. I guess I'm not going to demonstrate that. But those are the endless retries that are going to happen if you do nothing. If you just go with the defaults, that's how it works. And we're discussing earlier today, why is it done? It might seem silly, but there is a very good reason behind it, and we get back to ordering once again. Because if it wouldn't be like that, if we would allow Lambda to say, like, don't care about it, just jump over the next one, then the order will be lost. So we need to make sure that every single batch is processed in order until we move to the next one. So if something can't be processed, it's only natural that it will try again until something happens. So, and it's our responsibility to configure what should happen when the errors happen. And as I was saying, there is a lot of options for that. Okay, so this probably doesn't look too good, but we can easily configure a very quick improvement to that. So we will go to our trigger and scroll down to the additional settings, and here where all the error handling settings are. The ordering of those configurations make no sense to me. I don't know, I guess it's alphabetic, no, not even that, but whatever. Maybe some feedback to AWS is at place here, but so yeah, where was it? Additional settings, and here we can see that retry attempts and maximum age of records, they are both -1, which means no limits to nothing. So we will just retry as long as the data is valid, so for at least 24 hours. And here we can just say, okay, just 1 retry attempt and maximum of 60 seconds. And we just save it. And what we should see now immediately, without doing anything else, just deploying our Lambda, we should see actually that the retries have stopped if it will figure out that we have updated it. Yeah, so now you can see that's it. No logs are coming. Yeah, tell me.
If the batch window is longer than the time to live of the record, can it lead to a process?
It can't be, because time to live of the record is at least 24 hours. So you can't have a batch window that big. I think it's just, I don't remember.
What did you set to 60 seconds?
The retry attempts. Yeah, that's what you meant. Sorry, I didn't understand the time to live question. Yes, 60. It's either or.
Invalidated in 60 seconds?
Yeah, it's like in 60 seconds it's invalidated. In a sense, like it's still in the stream, it doesn't leave anywhere. The record still stays in the stream. Mm-hmm.
60 seconds.
Yes, exactly. So basically here we say you have 60 seconds to try to process this record, and if it doesn't work, then move on. But I mean, you don't necessarily need to use both of these configurations. I actually personally have always used just the retry attempts, because usually that's already good enough limit. But whichever one you use, just use one of them. That's maybe the main point, just whichever is more suitable for your particular use case. Like you can specify because retry attempts is a more common way to do things with retries.
The limit can be good if you want to like also cover the case when the Lambda just hangs on some event.
Yeah, sure.
So like I can see cases.
Yeah, for sure. That's what I'm saying. It's case by case. For example, if you have a big data application, sometimes in big data applications, some particular data is not as critical, like as the processing speed, for example. So if the data gets already out of the real-time range, then you're like, okay, I don't care anymore, just move forward. So that's very useful, yes. Give your head.
Isn't the retry attempt kind of anti-pattern? Because as far as I understood, the reason because the data is failing, it's the corrupt data. And like in the real life, no matter how many times you retry, and if you have an exception and like error, like you can retry it. It doesn't help.
Yeah, it's a very good question. Here it's more of illustration purposes. It's easier to explain with corrupt data, of course, but there can be multiple different reasons. One very common one, for example, if you have you make, for example, external API calls from your Lambda. You get some data and then you want to do something with it and you send an API request and that one fails.
Oh, yeah, I see.
So there's any failure situation, just with with corrupted data, it's easier to illustrate, but you're completely right, the data will not correct itself. It was corrupt, it will stay corrupt after 1 million retries, but it's just for the simplicity of illustration. But yeah, it's any error pretty much. And yeah, but the case that we had, we actually did have a corrupt data and we were just not smart enough to just say stop processing. It was on the constant loop, and of course nothing happened because the data was still corrupt after 24 hours. So yeah, very good question. So here we stopped all these retries, so it's already looking better. But let's just send another batch of records and see what happens. So all right, so we sent 5 records this time, so to see the distinction between the 3 records and 5 records, just for sake of simplicity. So here we are receiving 5 records, partition 0 is okay, 1 through an error, and then we have 1 retry, and that's it. So we just only have 1 retry, yeah?
Is there can I treat different errors differently? I mean, if we have 1 error, it will retry 1 time. If we have another one, then it will retry, let's say, 10 times.
Yeah, with these automatic configurations for the event source mapping, now you can't. It's left to your code then. You can basically, in your code, define when you allow your Lambda to throw an error and when you want it to stay or to take care of it within the Lambda function itself, because of course you can do some retry logic within the Lambda. But of course it's always preferable to automate the retries and error handling as much as possible, to have as little custom code for that as possible. But short answer, no, you can't do that with these configurations. Yeah, of course it can, but it will mean that you will send certain records to the dead letter queue, and then you will have to return to them with some different custom logic and process it differently. Of course, you can always implement custom logic for error handling. You just can't do this with these Lambda event source mapping configurations automatically, like for different errors, I mean. Yeah.
What about step functions?
Of course, yes, yeah. You can create a flow where you will have different options with different errors or with different situations. But here we are kind of trying to concentrate on what event source mapping can do without even using external services. So you can just use one Lambda service and try or do quite a lot with it already. But if you have a more complicated workflow, of course, you can separate it in different branches and go and use, for example, step functions is a very good option for that, yes. Yeah, the age of records, we're not going to separately illustrate it. It's pretty clear, I hope, at this point. So let's quickly go to the next one. It was the batch bisecting, so splitting the batch recursively on error. Here it is. So it's just one checkbox. So it says that if the function returns an error, split the batch into 2 and retry. So that will be handled by Lambda. You don't retry anything, you don't do anything. Lambda will do that for you once again. And split the batch on error. Yes, so it got maybe updated. So let's try and test it once again with batch of 5 should be fine. And this, I'm pretty sure we're going to get a demo effect here, but let's see. And I'll explain, if we do, I'll explain why that happened. But 5, yeah, that's exactly what happened actually. So the thing here is the, let me see, eventual consistency. Yes. So if you are working with the cloud, there is always a thing called dimensional consistency. So the changes get propagated, for example, different availability zones within the region. And even though in the console you would see that the change was already, in fact, propagated, the thing is that probably it didn't get propagated to all the regions. So we need to wait some time before the change gets into action. So this is my favorite issue with the live demos. You never really know when the eventual consistency will come in play. And somehow with this batch bisecting, I have been seeing it maybe more often than with other things for some reason. Maybe it takes some more reconfiguring for AWS behind the scenes. Here it is. All right, so not so bad. So first we receive the batch of size 5. We have seen this before. But then we receive a batch of size 2. So Lambda split the failed batch. So now we only have partition key 0, partition key 1. That true never again. Then it splits that batch one more time. So we have the partition key 0. And this time we finally print our data because we only had one record. It went through and we finally got to the end of our function. And we print our very important data here. And then it's the batch with failed records. So it fails. Then it fails probably one more time because we had one retry attempt. And then we get all the remaining data because we kind of stepped over that one bad record. And ta-da, here we are. We finally printed all our extremely valuable data here. So that's and those are the old logs, so don't pay attention to those. So that's the batch bisecting for you in action. It's pretty useful, but you can see here that record 0 or partition key 0 was processed multiple times because we split the batch and then we try again, So you might end up reprocessing some of the records many times again with this batch bisecting, but at least you have much better chance to end up processing all the remaining records at least once. And on that note, AWS Kinesis in general offers you or promises you at least one guarantee, so to speak. So it promises you that the data that you write to the stream will be in the stream, it will be written there, but it doesn't guarantee that it will be written exactly once or that you will consume it exactly once. So it will be there, but you will end up when you are consuming data from the stream, you will end up seeing duplicates at some point, again, with a big enough amount of data. And this, again, is a very common consideration with distributed systems in general. It's close to impossible to have exactly once guarantee. Even those who promise exactly once, like Kafka, they don't deliver on that. They still will have duplicates at some point. So it's your responsibility when you are writing a consumer to create your downstream application in such a way that it will tolerate the duplicate records because they will happen. That's like a fact of life. But still, reprocessing with your Lambda, reprocessing the same records when you can avoid it, it's never a good idea. So it's better to avoid it whenever you can. And here we come to the next. Oh, not here. Let me see where I was demoing. So let's try it here once again.
Probably exactly once you can process if you put batch size 1 and sequentially process and fail every single time. So if you
yes and no, because yes, but you will have also on the other, when you're writing data to the stream, you will also end up with duplicates because again, that's something I haven't touched on completely, but again, there will be, because you write data over a network. Network will fail, there will be delays, there will be timeouts, you will retry the same record, your producer will retry the same record, and you will end up with duplicates. There's no way around it. So kind of you always need to assume that there is a duplicate data in your stream. So if your downstream application is sensitive, you always should implement that yourself. So it's kind of a rule of thumb, basically. Doesn't matter what service you are working with, that's just like the reality of life, let's put it so. Yeah.
Is there a way to infrastructurally still save a failed record?
Yes, there is a very good question. I hope we will get to this. If not, in the very end, I will just briefly mention that. Yeah, so what I was doing here, I was doing the partial success. So here we are, and we scroll once again to some uncertain location. Here it is. Report batch item failures. So allow your function to return a partial successful response for a batch of records. So here we actually utilize the synchronous nature of our invocation, and we return to the event source mapping the actual failed record. So we said that, hey, this record was the one that failed, so please don't process anything, or don't return me anything that I have already processed before that record. Let me see what's the, yeah, let's do that. So for that, actually we need to make some changes to the code in our consumer. And let's go to consumer, and let's comment this out, and then uncomment step 2.2 and deploy. So here we actually return something from our Lambda function for the first time ever. Let me show you what we do. So the function name is process records properly. That's exactly what we do here. Here it is. So here is pretty much like here before this we had just simple code with like map of records and processing each of them. Here exactly the same code, we just wrapped it in a try catch block, and then if we have a failure in the end, we return an object that looks like this. It's a predefined structure of the object that you need to return to event source mapping. So you return batch item failures, which is an array which ironically will contain just one element. You can't return more than one, it will ignore it, or you can, but it will ignore it. But anyway, you return the sequence number of the failed record. So if you remember, I briefly showed you in the beginning that each record that you write to Kinesis contains some metadata, and one part of that metadata is the sequence number, which is the unique identifier of your record within that shard or within that stream. So what you need is when the record fails, you return the sequence number of that data to the event source mapping. And here we basically cheat because we know exactly which record we are going to fail because we fail it ourselves. So we just pick the sequence number from that record. But that's the part of metadata. It's very easy to pick from the record, just like this, basically. So we return that sequence number to our event source mapping, and it should work like that. Let me see. Yeah, let's test it. I guess that should be enough. Yes. All right. Batch 2. Why? What happened? I didn't show me the last one. So here is our batch, 5 records, 0, 1, 1 failed. We have seen this before. And here we receive a batch of size 4. And it starts with a partition key 1. So we told the event source mapping that the partition key 1 was the one that fails. So I was like, hey, I'm not sending you the partition key 0 anymore. Let's start with this one. So we basically avoided all that reprocessing that we just saw before that. So we started again with this, and then it will continue with batch bisecting. So it will split it again and try it again. So all the same things that we just saw before. But we just eliminate that reprocessing of the already processed records if we tell the event source mapping that those were the failed records. So we are getting already pretty good at handling errors. Yes, please.
Why is it bisecting again if it knows that it's always the one?
Well, it doesn't know that it's always. We know that it's always
It
one.
also passed that information.
Yeah, but it retries it. You know, it hopes that it will succeed this time, like I said before. And it's kind of the point of this partial success thing is that it will skip the ones that it already processed before. You know, so that's the entire point of it.
I think would it be smarter to retry only the ones that fail?
Yeah, well, it would be smarter probably, but that's not a. I mean.
Because we are getting extra retrieve times, right?
Look, it still retries. In a way, it still fails always on that. So it doesn't go further than that one.
Yeah, but it takes longer to start processing the other one.
Not really, because it did split it. So the splitted parts, they are processed in parallel.
Okay.
So in theory, it shouldn't make sense. But yeah, well, that's the algorithm that they are using. So it's hard to say would there be a smarter way to do it. But that's how AWS decided to implement that error handling.
There is no way to.
Well, not always, no, but you need to make choices and trade-offs when you implement anything. So that's the trade-off they went with, I would assume. But it's really hard to guess why they make certain choices and not the others. We can only speculate about that. Yeah, and of course you can do all that in CDK. It's been a while since I showed you that. But, actually, I don't even have it separately here. But you can create, and here actually, we get back to the question about what happens. 5 minutes is too little. So what happens is if all else fails. So if nothing works and we still fail, we don't really want to discard that record altogether in most of the cases. We want to send it to a so-called failure destination. So to do that, let me just deploy so I can maybe at the same time illustrate how you would do it with CDK. I think it's the first time we are deploying today. So I'll comment on this one and uncomment the one that is used for failures. And I'll explain in just a sec what it does. So we just write CDK deploy, and magic should happen if the internet works, which is not a given, of course. It probably will ask me something. Yes. Okay. So here, if all else fails, we configure the own failure destination, which can be either SNS or SQS, acting as a dead letter queue, basically. And what will happen, though, in the console, if you go check it out, you can, of course, configure it the same way as you did everything else, or as I did everything else. We go here, we edit it, and go all the way down to additional setting. And here, the very first one is the on failure destination. It says that Lambda discards records that are expired or fail all retry attempts. You can send discarded records from a stream to an Amazon SQS queue or an SNS topic. So it says that you can send discarded records, which is not entirely true, because what we send there is the metadata about the records. So when a record fails after all the things that we have done, we can tell Lambda that it will send the metadata of that failed record to, for example, an SQS queue, and then using that metadata, you can pick that record from that stream later with some custom processing, like maybe separate Lambda or something else. You have maybe a step function for that. Unless it is still valid. So the data will still expire in 24 hours by default, or the way you configured it. So let's assume your stream retains data for 24 hours. So all the data expires in 24 hours after it's been written, and it's the same for the failed records as well. So if Lambda couldn't process the record, it stays in the stream, and you have to process it within the 24 hours, or it will expire from the stream. So that's maybe the main caveat here that you need to keep in mind.
So in that case, you would maybe trigger something straight away from opening the record itself somewhere.
Yes. Exactly. So you would probably want to create some custom process for monitor that letter queue, and whenever something arrives to the queue, you probably want to trigger a process that goes and tries to fetch that record from the stream and do something with it, because otherwise you might end up with an expired record. Just let me see if this got updated. Yes, it did. Let's hope it actually did, which is not a given. Yeah, here we go. And here we can see that, yes, now we have a non-failure destination, which is our dead letter queue. And why I did it with CDK, because CDK actually also adds all the necessary permissions for your Lambda to write to dead letter queue. That can be one problem if you forget to add permissions. Well, it can't really send anything to the destination. I don't remember, will it fail the Lambda itself or not, but you will not get any information in your dead letter queue. But now all permissions should be in order, so just let's test things out. Let's see. Yeah, let's just test it out and hope for the better. Again, this is one thing with the eventual consistency coming in play almost always. Let's see if that happens now. Well, this is the easiest way to check. Yes, so here was our dead letter queue. I'm now in SQS console. So we have our consumer Lambda dead letter queue that was configured by CDK. And here we can see that message is available 1. So let's go check that message real quick, send and receive messages. Again, very intuitive interface. So we poll for records, and here we have 1 record. Let's check it out. It used to be a very nicely decorated UI, now it's not. So you have some information here in general about what happened. So we know that this came from Kinesis consumer Lambda. Approximate invoke count is 2, so it retried it 2 times before it failed. And here is the actual data that will help us retrieve it from Kinesis whenever we need it. So it tells us that the shard ID was this. Well, we only have 1 shard in our stream. Yeah, 1 minute, 2 minutes. Yuri will have a shorter demo. So, and here we have the sequence number for that record, so we can go and pick it out, and some other useful information like the name of the stream itself. So here we can see that information and can pick it up later if we want to. And
Sorry, is it combined with this bisect strategy?
yeah, that's, I mean, now at this point we actually have all the configuration on. So here was our, this is like the all-consuming error handling configuration with retry attempts, maximum record age, bisecting, failure, reporting on failure, and then we have if all else fails, then we have. So after all the retry attempts, if nothing worked, before discarding it, we send information to the on failure destination. And like if you look at the logs, that's like, well, I'm not going to show it again, but that's the same process that we have seen already. So it starts with it, and then it's kind of bisects it and retries it, and so on and so forth. And one thing quickly I wanted to mention, because it's sometimes confusing for people, here, whatever I was describing here is the event source mapping configurations that we can use, and they are very extensive, as you have seen. But if you have worked with Lambda, or if you go check Lambda, there's actually, in the configurations, there's this thing, asynchronous invocations. And in asynchronous invocations, there are actually also some settings for maximum age of events, retry attempts, dead letter queues. So let's go edit it. So here, for example, you can set maximum retry attempts from 0 to 2, so very limited actually, but you can do that, and then some maximum age, and then some dead letter queue. But the trick here is that, as I was telling before, this is a synchronous invocation model, so poll-based synchronous invocation model. So those settings that I just showed, they only apply for asynchronous invocation models. I have no idea why they don't disable it altogether when you are using, for example, Kinesis as a trigger. Well, actually, there might be some good reasons, now it came to mind. But anyhow, you can't use these asynchronous configurations when you have event source mapping involved. So with things like Kinesis, SQS, Kafka, DynamoDB streams, all of those services that use event source mapping, you should always configure failure configurations or retry configurations in the event source mapping itself, not in the Lambda. So this can be a bit confusing, but just don't touch those because they will just not work. That's maybe the bottom line. And while we're out of time, so I'm not gonna demo, unfortunately, the filtering, which is basically very simple. You just add a filtering criteria. I just can show the code here. It also has the code, so you can try it out yourself. So we just tell, for example, to our Lambda that, hey, we only want to get records with partition key 2, or only get records that has data, it's awesome, written in it, or whatever you want to. So it's just, if you're familiar with event bridge filtering, this uses the exact same syntax, so it should be really straightforward to use it. So you can do that with, once again, the event source mapping. And the very last one was the tumbling window for some real-time analytics. Well, that I'm for sure not going to go into because it would take 10 minutes. But again, you have the code for it, so you can try it out on your own. And then there is the Lambda code for that as well here. So if you uncomment this step number 3 and comment this out, you can actually pass the state between different Lambda invocations and do some cool aggregations or analytics within a window of 15 minutes. So this is something cool I would recommend you to try out if you are at all interested. But now I'm really out of time, so really sorry for that. Always takes a bit longer than you expect, but I hope this was useful the way it was, and thanks a lot for coming. And yeah. Thank you.